So to answer the second question in this problem, the second question was, what is the maximum possible downward acceleration? That is simply 9.81 meters per second squared, which is the acceleration due to gravity, because weight is the only force that will cause the elevator to go downward. So the cable is not going to push the elevator downward. Okay, for the next problem, a 12-kilogram block A hangs from a string, that is string, that passes over a pulley and is connected at its other end to a 30-kilogram block B, which rests on it's important to take note of this, frictionless table. Find the acceleration of the two blocks under the assumption that the string is massless and the pulley is massless and frictionless. The question is, what is the tension in the string? So of course, we need to draw an FBD for this problem first. So we have two blocks, block A, which is hanging, and block B, which is resting on the table, and they're connected to each other using a massless, frictionless string. So let's draw first. So if this is our table, this is the table, and then we have a block. We have a block which is resting here. Okay, that is block B. So the mass of block B is 30 kilograms. And then there is a pulley attached to the end of the table. And then this block B is connected to a string that passes over the pulley. And then at the other end of the pulley, we have another block that is hanging. Okay, that block has a mass of 12 kilograms. So because the table is frictionless, so even if mass B is heavier than mass A will be able to cause the movement of block B. So in what direction will these blocks accelerate? So while block A will accelerate, well, let's start with A. Block A will accelerate downward. That's the acceleration of block A. And block B will accelerate towards the right. So since the two are connected using the same massless frictionless string, we expect them to have the same acceleration. Now what causes this acceleration? This acceleration is caused by a net force. So the net force that causes the acceleration on block A, we will assign that as F of A. Okay, net force on A. And the net force acting on B will be F of B. Okay, net force on B in the same direction as the acceleration. And then we consider the forces acting on the blocks. So let's take a look at block B. So looking at block B, if this is our block B, there are actually three forces acting on block B. What are these three forces? Number one, it's the weight of block B. That's FWB. Okay, remember for convention, we use FW for weight. And then we have an upward force. Let's use that FNB. Okay, that's a normal force, and we're going to talk about that in the next discussions. And we have the force that's directed towards the right, which is the tension of the string. Okay? And then the net force is directed towards the right. That's F of B, which shows us that the tension of the string here on block B is simply equal to the net force acting on block B. Okay, this is block B. Now, how about block A? What are the forces acting on block A? So let us draw block A. Okay, so if this is block A, then the forces acting on block A are, okay, there's no normal force because there is no contact. No. If this is the action force, this is the weight of the block B is the force acting on the table, then the normal force is the force that's the table is exerting towards the block. But because block A is hanging, then the forces acting on it are simply the weight of block A, which is directed downward, and the tension of the cable, which is directed upward. So, is this tension on block B same as the tension in block A? The answer is yes. Why? Because we are referring to the same string, same cable. So, in what direction will block A move? It's going to move downward. That's okay. It's going to move downward. So F of A is directed downward, which means that if we know this is the net force, this is the net force, meaning this is the difference between the tension and the weight of block A. How come we say that FB is just equal to the tension here in block A? Well, there are no other forces acting, horizontal forces acting, no, on block B. So therefore, the net force is simply equal to this tension here, T. There is no opposing force because the table is frictionless. But here, the acceleration of the object or mass B is directed downward, which tells us that this is simply the difference between the weight of object A or block A and the tension. So because the movement is downward, it tells us that the weight of block A is greater than the tension. Okay, so what equations can we draw from the two FBDs? Okay, let me just rewrite this FA here. The bottom part. So FA is net force on A. So drawing an equation here, tension on block B, tension is equal to F of B. But then the net force on B is simply equal to the mass of B, block B, times its acceleration A. Let that be equation number 1. In block A, tension, or rather the net force B, or A, is equal to the weight of A minus the tension. So tension is equal to the weight of block A minus the net force of block A. But the weight of block A is equal to the mass of block A times acceleration due to gravity minus the mass of block A times the acceleration of block A. That is equation number 2. So equating the two equations, equation number 1 equals equation number 2. That's MBA, because both the bar are equal to tension, equal to T. So we equate the two. MBA is equal to MAG minus MAA. So remember, the mass of B is given, the mass of A is given, and the acceleration due to gravity is given. So meaning in this equation that we're able to come up with, only the acceleration is unknown. So what we're doing here is we solve the acceleration of the two objects, of the two blocks, and substitute it to either equation 1 or 2 to finally get the tension, which is our target for this problem. So we combine together the terms containing the variable for acceleration. So MBA plus MAA equals MAG. So you factor out A. So take note that even if we are given these masses and the acceleration due to gravity, I'm not yet substituting with the values because I want to show everyone how equations are derived. And also, so that substitution will be done at the end of the solution. So MB plus MA equals MAG. So acceleration therefore is equal to MAG over MB plus MA. So we can now substitute. The mass of A is 12 kilograms. Acceleration due to gravity is 9.81 meters per second squared, divided by mass of B is 30 kilograms plus 12 kilograms. So could you please solve using your calculators? What is the acceleration of both blocks? Are you solving? So the acceleration of both blocks is 2.80. The unit is meters per second squared. But this is not what we are looking for in the problem. We are looking for the tension. So to solve for T, substitute in either equation number 1 or 2, but let's use equation number 1. Substitute because it's a shorter solution. Substitute A to equation number 1. So T is equal to MBA. Mass of B is 30 kilograms times acceleration due to gravity is 2.80 meters per second squared. So the tension in the string is equal to 84.09 newtons. So if you're going to substitute in the second equation, you're still going to get the same answer.